Hi, how's it going? I'm Malachi, CEO and engineer of Elite Automation. So if you follow us, then you probably already know that we're systems integrators, that we do all different types of robots. fanuc is one of our primary robots that we integrate. We do everything from pick and place, palletizing, all different types of applications. And this is just one of the brands that we work with. We work with many other brands, and we're going to kind of take you through today some of the other booths that are at this MODEX event. So this video right here is really going to be revolved around being a MODEX related video and kind of showing some of the different technologies that are out on the market and some of the different types of technologies that we integrate. So this is one particular piece of equipment that is kind of newer on the market, and it's opening up a ton of opportunities for what you can do as a manufacturer. This is a bin picking application. It's using fanuc's 3D vision. And what it's doing is, if you come over here, I can kind of show you on this screen how it's locating the parts. It's pulling the dimension of the part and knowing its Z height as well. So that way it knows the orientation, the height of the part, and is able to go down there and pick up the box or the item. It could be anything. So this application can be used for a ton of different things. This particular application has just been set up for boxes. You can do cylindrical items as well. So this is definitely a solution that can help you in automating your manufacturing facilities. We actually are in talks with some other customers with doing a very similar topic like this, or a very similar application like this, doing cylindrical items. All right, so this is also another bin picking application. The technology behind it's the same, just giving a demonstration that's a little bit different from just picking from a bin and placing it into another bin. This is more so you could say a line tracking. They're actually probably not using line tracking on this particular system, because if you notice, it moves, the conveyor belt stops, it's acquiring an image, and then it's using that data to place the robot. Whereas if you're using line tracking, you can make it so the belt never stops. You can acquire the image further back, and then as it gets into the robot's reach, it becomes an item that the robot can pick. They're also doing another inspection right here, and to be honest, I'm not quite positive what they're doing with this particular inspection. They could be doing verification of placement. They could be doing a barcode or scanning. Let me see what's up. It's not a 3D camera, I can tell you that. Oh, it is 3D. Okay, so it is a 3D camera. So they have to be doing some type of dimensioning or something along those lines, because if not, you don't have a real good use case for using a 3D camera. All right, so here we have a palletizing system. This is another one of the applications that Elite Automation does. Basically, this particular application is just kind of showing how you can, pick and make a decision whether it needs to go on this bottom conveyor or this upper conveyor. Maybe it's the product that's on the conveyor, or maybe it's the product that's on the pallet, and that's why it needs to go to a different conveyor. Or maybe the top conveyor gets full, so you need to transition to the bottom conveyor. And then another thing that's really cool with palletizing applications, I'm gonna take you over here to the HMI that fanuc has created. So we do these types of HMIs as well, where, say for instance, if you have certain layer patterns that you want to teach, like you see this one's like 6 and all on the long ways, or you have 2 of them that are based in that orientation there. These are things that you can do in the HMI, and the things that we can program for you guys. And this kind of depends on the customer, on what they want. A lot of times we will give the customer the ability to teach in the layer, but we'll do the actual box sizing on our end. So we will use technologies, or we'll have you enter in like the box dimensions. So let's just say, for instance, it's a 200 millimeter box by 50 millimeter box, and you put that into your recipe. Now the robot automatically knows the size of the box, and so as it comes into our systems and we start sorting layers, it knows that it's like 50 millimeters, 100 millimeters, 150 millimeters, 200 millimeters, and so forth. So it automatically does the math. You don't really have to worry about doing that type of math. You just tell it how many items you want on the particular layer. Or if you're a type of company where you only have a few layer styles, this is a really good option. But we, a lot of times we'll deal with customers that have way more than, 6 different layer styles, 8 layer styles. We might have customers that have 80 layer styles and 80 different like size boxes that they're running on their lines. So a lot of that plays a factor in how we can develop a system and what's the right system for you. But these type of technologies are super powerful. I mean, the palletizing's been out here for a while, but like the fact that you're like able to auto detect box sizes, like that's a big thing. Like pulling from the pallet and going to the pallet in a simple application, there's really nothing to it. That's been around for a long time. But to have an auto-adaptive robotic cell where you can feed us a box of a certain size and not even tell us what size it is, we can pull those measurements in. Very similar to the beginning part of this video where you're seeing bin picking. We can use the values that 3D camera gives us to know the size of the box, so that when we go place the box onto the pallet, that the robot auto adjusts its positioning so that there's no gap between the boxes. Okay, so here we have another example of a 3D application where basically there's a couple things going on here. This robot is actually just picking up the random items out of this box. The vision is basically just giving it the location of the item. And I don't know what's going on in the background 100% because I didn't code this, but I'm assuming what it's doing is telling it what part type it is. So that way it knows the best pick location for that particular part type. So if you see if it's a green part, it has a pick location. If it's a red part, it has a pick location. So it's identifying that part. And then when it's going through this chute right here, and they're using a diverter, which I think they're still using that 3D data. They could be doing this different ways. They could be either doing color detection, or they could be using that 3D data and line tracking that down the line, or just having not even really a line tracking, but more like a part recipe tracking, where they know that this part coming down is the white part, or it's the blue part, or the green part. And then over here, you'll see this other robot. It is taking the already sorted items and it's building out an order. So if you see actually on this screen here, it might be hard for you guys to see, but it's saying this current order should get one of the blue bottles, 3 of the green, 2 of the white, 2 of the red. Now your order just changed. So they're giving this a different pick order. So it's a good example if you have like sortations, or you're packing orders for smaller customers. So if you do orders for smaller companies like a Dollar General or something like that, or you are a Dollar General and you're needing to ship out to your stores, and you get 6 deodorants and 7 sunscreens, an application like this is very good for that. So this can already be picked. And then maybe you can either have a human kind of rearrange items if they need to be, or maybe if you're just okay with shipping items that are kind of just thrown in a gaylord or a tote like this. But overall, 3D vision is great for being able to do stuff like detection, what you're actually picking, how to pick it. It's really a technology that came super, super far in a period of time. If you can see like the different details of these parts, I mean, they have quite a bit of different shapes to them, and you see it's picking these parts accurately every time, which is something that was like 2 years ago, 5 years ago was not even a thing. It was just highly inaccurate, and this accuracy just really skyrocketed. So here we have a fanuc CRX robot, which is their collaborative robot. And if you ask me, in my opinion, it's probably one of the best collaborative robots on the market. We have done more UR robots more than any other application, but that's because up until a couple of years ago, fanuc was so much more expensive and wasn't really trying to compete with UR. I think they were like almost double the price at one point from a UR robot, but they've significantly lowered these prices of these robots to be more affordable and be way more competitive with UR robot. And if price is not an issue, you 110% with the CRX option. Just having the fanuc platform and the ability to kind of have the same programming user interface from fanuc. It's much more powerful than UR robot. And the big thing with collaborative robots, you do stuff like that, you hit your robot, or hit you probably, and then you're able to cycle start it again, and your robot will go back to running. It prevents a lot of injuries from occurring. And you're able to work with this robot as we are right now. And if I wanted to, pick this piece up and do something with it, I'm able to do that while the robot's doing the exact same thing. So that's kind of one of the main advantages for doing a collaborative robot. And also the quick deployment, you can quickly deploy them, and you can also move them around and repurpose them in different areas of your plant within literally a day, not even a day, especially if you've already programmed that particular area in your plant. All right, so you see this over at the fanuc palletizing application. So this is Kawasaki, and like I said, we work with all different types of brands of robots. We pretty much don't have a limitation We've really diversified our company and being able to handle all the different robot brands. So things that I am weaker at, I've hired individuals who have expert strengths in it, whether it be the brand of robot or the particular type of application. Like I've done a few welding applications, but I've hired guys who have done entire BIW line, body and weld line type of applications. So as you can see here, just another simple palletizing application from Kawasaki. Kind of just doing the same thing. Just wanted to show you guys some of the capabilities of some of the other robot makers, and kind of show that all the robot makers out there are kind of able to handle majority of the same applications. There will be some more detailed differences between the two and their technologies and whatnot, but that's something we can handle in a deeper later video. All right, so here we are at the Kawasaki booth still. Here we got an application where the robot is taking a vision snap and it's also doing line tracking. So like I was saying before, I don't think the other system was doing line tracking at the fanuc booth or the fanuc robot cell that we was at. And if you haven't seen that full video, make sure you watch the full video. These might be chopped up in clips of videos. So this particular robot, the main thing that's doing, the main technology that is different with this particular robot is it's snapping an image up here, but it's snapping an image from that back side of that conveyor, and then as it travels down, the robot will get to that item as soon as it can get to it. So like, see how multiple come in at the same time? So it's gonna snap those images, it's gonna get the location of each one of those images, and then that part is being tracked all the way down. So it knows like part 1, part 2, part 3, part 4, and it has the location data of each one of those items that we need to pick. All right, so now we're over here at the Yasukawa booth. This is another palletizing application. Again, we're really just trying to show you guys that like all of these brands are really starting to be able to have the same type of capabilities. One thing that is cool about this one is it's actually a collaborative robot. And whereas we've been using UR a lot, and because of the cost effectiveness, they were a much cheaper robot, much more affordable, I should say. One of the main advantages now with some of the other makers, with like fanuc and Yasukawa here, you see the size of this collaborative robot has gotten much bigger. Whereas the largest UR robot is actually quite a bit smaller than this one, and probably especially in payload as well. I'm not sure the actual specs on this particular collaborative robot, but I do know that this one will have a much higher payload than what a UR robot would have. fanuc's CRX robot probably is around the same range as this robot, but I'd have to look at the specs to be able to really tell you that. And if we were looking at a particular application, we would help you find the proper solution for what is the best robot solution for you and what's kind of the easiest for you to work with, what fits right for your application. All right, so here we are over at the AVB booth. Here, a couple things that you see a little bit different in this one is they have a gantry style setup, so they have their robot hanging from the ceiling, which is an option for majority of robots. Here they're also doing like a bin picking type of application. As you can see, we have vision cameras up here on this top side. And as of right now, it doesn't look like they're really doing too much technological decision making on where they're putting what. They're probably just putting X amount in this one, X amount in that one. They're not really doing too much organization with it. That's just probably what they're doing for their demonstration sake. All right, so we're over here at the UR booth. Right now, they're basically just doing another palletizing application. UR, their big thing is their collaborative robot. They're kind of killing it in the space of marketing. They're one of the robots that you can also work around with, so it's collaborative. You can work around these robots. You're able to bump into them, hit them, they can hit you, and there shouldn't be any harm. And you can do just about any type of application with it as long as the payload can be handled. I kind of want to stop the robot. They may have upset with me, but I think we're going to do it anyway. Oh, didn't stop it. Wait till it comes back up, see if it comes back around. And so you see right there, kind of a small tap, hit it, and you should be able to just kind of restart it again. There's a enable robot on here, and it should be good to go. I need to play. Into that, it's paused. Yeah, it's got the start button. I don't know where the cycle start button is, but...
A few moments later.
You have cycle start for this? So I smacked her, I got hit by the robot, now what? I hit enable, yep. Okay, that's what I thought. I couldn't see it down there though. There you go. And see, that's how quickly it goes. I could be the operator that don't know what I'm doing. And you have your back up and running again. This is a great solution. All these collaborative robots are a great solution, and they're fast to deploy, they're fast to adapt and change them to different locations. Really, that's kind of one of the biggest reasons why we use them. You can use them at the end of one line and then shift them, move to the end of another line. Go ahead and follow me over here. This is kind of a good example. Like, say for instance, you could be unloading a mixed pallet and having a vision system like this one up here, where you're locating your boxes, and then from there the robot knows where to pick it. And also you have this curved conveyor, so if you need to curve your conveyor out this way, curve it out another way, or you could have two conveyors sitting side by side and have the robot feed out to two different directions if that's what you need to do in your operation. So hopefully that gives you a good example of what UR Robot is, what they do, and if there's any solutions we can help you guys with, or they can help you guys with, just reach out. Okay, so we're still over here at the AVB booth. This is what's known as the AMR, which stands for Autonomous Mobile Robot. These are becoming a huge thing within the industry right now, because logistics is so big, and instead of having conveyors run hundreds of feet to be able to transport product from one area to another, these also have a much higher adaptability. As of right now, we haven't done much with the AVB version of this, but we have done a ton with the Mirror platform. And so like something that you would utilize this type of system for is this AMR could go up underneath that cart there, and it could pick up the entire cart and take that cart to another area. They have top modules where there's pins that will locate that cart that it sits on, or you pick up the pallet itself. So you don't have to pick up the entire cart, you can just pick up the pallet. And you can also adapt these things to have different top modules. This one right here in particular has another cart style system, so you can use different types of cart systems. I mean, this could even be used in like a hotel application. And we're in the manufacturing space, but we'll dive into whatever space needs our services and solutions. Another thing that we see put on these, and that we've put on these in the past, is we put conveyor top modules on them, so that way you can feed from one conveyor onto the Mirror's conveyor, and then take that Mirror somewhere else and offload onto another conveyor. And that's opening up a ton of opportunities, a ton of doors to things like having consolidated robot cells, where you have one robot cell and you have 6 different lines that feed that one robot cell. So instead of having to have 6 robots at the end of each line, you're able to consolidate that to just one robot cell, and then maybe a couple AMRs to go to the end of those lines and pick those up. So these are really a huge thing that are really just interrupting the manufacturing industry. I'm just turn around right here and just show, like, here's just like another system of these type of AMR systems that are just doing another logistical task. It's picking up stuff from one area, storing them in a location for a period of time, and then doing whatever the next step in the process may be. And that's kind of what we do as a company, is we help provide those solutions. We help kind of help our customers like decide what they want to do, what they need to do, what the strategy is. And so we'll do it on a project basis, or we'll do it on a consultant basis, and we will basically help somebody just map out their whole entire automation plan if they're new to automation, or they don't know what may be the best things to go ahead and start automating with. Guys, I think this may just wrap up our MODEX event. We're on the last day. Everybody's wrapping up, rolling out. Hopefully this was useful content to you guys, and this might also go out as micro content, so if any parts of this seem weird, that's why. Yeah, thank you guys for viewing, and we'll catch you on the next one. Subscribe to our channel, because we're going to be doing tons of these events this year. It's going to be wild. Catch you on the next one.